Hello, welcome to this course. In this course, we will focus on parts of SQL specific to data analysis, and for attending this course, you don't need any prior data analysis experience. For this course, we use the PostgreSQL for demonstrating the queries, and the database we use is named as Pagila. Pagila is a DVD rental store sample database for PostgreSQL. It is open source. I will provide the link below this video. Let's briefly talk about ER diagrams. ER diagrams is a common way we visualize the database. Here is a sample portion of ER diagram for the Pagila database. These diagrams include a name for the table and a column name, and also how all the tables are related together. I have included a full image of ER diagram for Pagila database below this video. Why do data analysts use SQL? Most of the data needed is in the database, and to extract this data we need a SQL query, and it is easy to understand and easy to replicate. We can run queries on multiple tables at once, and also if you consider spreadsheet, we can at max query 1 million rows, but with SQL you can query a billion rows. And also you can ask deeper questions, like rather than just answering what is the most viewed page, we can also ask deeper questions like how many users web page has for the last few weeks, last 3 to 4 weeks. So these kind of deeper questions we can ask with SQL. For this slide, let's think a database is a bunch of Excel spreadsheets sitting at one place. Not all databases are a bunch of spreadsheets, but it's okay to think that way for this class. In a normal spreadsheet, we have rows and columns. The same way we can consider a database table, but with few differences. Like a row can be uniquely identified in a database table. Each column in a row will have a data type defined for it. For example, if we convert this spreadsheet into database table, then we define a data type of string for country and number for gold. So let's see different types of databases. There are SQL and NoSQL databases. For SQL, the most famous ones are Oracle, MySQL, PostgreSQL, and Access. For NoSQL, the famous database we use, popularly used, is MongoDB. But for this course, we just limit to the SQL database and also the PostgreSQL. Mostly, the queries we use in PostgreSQL will be applicable for all the databases. There might be some queries there might be some slight differences between the databases and how you write the query, but each database has a very rich documentation where you can figure it out from. Let's see some common statements that we use in SQL. So create statement is something we use to create a table, and drop statement we use to delete a table. We'll see a later video on how these statements are used. Select statement indicates which columns you want to extract in a given table, and from specifies which table you want to select the columns from. So basically, in select, after the select statement, you can mention which columns you want from this table, from the orders table. The formatting practices when we write a SQL query is actually we write the fields that we use, the columns you want to extract from the table in smaller case, and also the table name in smaller case, and the statements like SQL or from, we use we capitalize that. And it's not a good idea to write like a few letters capital and few letters non-capital. Although this statement still works, this query still works, but it's not a good practice. SQL query is not case sensitive, so this query will also work, but it's a good practice to write in this way. Limit in SQL is a statement that we use to limit the number of rows you want to extract from the table. So this, when we run this query, we just extract the 10 rows from the payment table, and we have a order by statement. So order by is basically you mention a column name, and by default when you mention for purchase date here, the query result will be shown in ascending order based on the purchase date. By default it's ascending order, but if you don't mention if you mention DESC, which basically makes the result to be shown in a descending order. So we can also filter the data using a where condition. So we can actually, if you want to query basically all the payment records where the amount is greater than 100, basically you can use this where clause or where statement. In SQL basically supports all the arithmetic operations. For example, if you want to extract the amount, the value divided by 30, and then you can use the slash, or if you want to just multiply the amount, the column, all the values in the column amount with 30, you can just use star. And similarly for addition and subtraction, we use plus and minus. So the as here, we can use as for basically defining this value. So when you run this query, the result, the column name will be shown as in the result for this value. In the result, the column name will be shown as divide by 30. Later we will run these statements and we'll see how exactly to get a practical exposure. SQL also supports logical operators, for example like. So this allows you to perform operations similar to be using where, but for cases when you might not know what exactly you want to search, you are searching for. For example, you want to just search a part of the string and see all the similar strings in the table. For example, for in, this allows you to perform operations similar to where, but more than one condition. Okay, and not is basically used with not in or not like. If you don't want to fetch records that are not in some values or not like some values, and also and between. Let's see these examples so that it will be making much more clearer. So now in the like, this like statement, in this statement, actually we use we are searching for all the strings for name. This result will be showing you all the rows that has a name that has this OHN, so as a part of the string. So that is how we use like for. And in, you will be using it if you want to search for multiple columns, multiple values. So this will be searching for all the organizations where the name is either Google or Microsoft. Sorry, this is, yeah. So we are just searching for the org names, like if you are just seeing if there is any org names that has Google and Microsoft. And also this is also searching the org names. Sorry, this is also org name. We're also searching org names. Select all the org names which are not Google and Microsoft. And also if you want to see like two conditions, you can use the logins. If you have a column logins made, check all the logins if the logins made is greater than 100, and if the user is a active user. And also we have like we can use like if we want to filter all the users with age between 20 to 25, and also if you want to filter all the users with age greater than 20, or like some any one of the condition, if it's matched, we show the names of, we just want to query the list of that users. Let's learn what is an inner join. Consider you have a orders table with the columns order ID and the customer ID and the order date, and we have a customers table with the customer ID and the name of the customer and the country. So consider you have to write a query that should output you the name for each order, the customer name for each order. So if you see, the name is in the customers table and you can't get in the orders table. So what you can do is, you can first think how these two tables are related. So these two tables are related on the column customer ID. So there is a SQL keyword called inner join. So what a inner join does is, it selects all the rows from both the tables on a matching column. So here our matching column is the customer ID. So now if we run this query, we will have the order ID and the name based on the matching column, that is customer ID. So if you see here, for order ID 1, it will be matching with this 2. So the name is Rachel, so it gets printed here. So that's how this table will be populated. So inner join selects all the records only if there is a matching column value. So what I mean by that is, for user 3 there is no orders, so when you run an inner join, you won't be able to see that record because there is no matching order for that user. So you might be wondering, how can you output the users with no orders? So for that, we have to do something called outer join that we will learn in the next class. Outer joins. We have three types of outer joins. When we perform inner join, we select the records that are present in this intersection. All these three joins contains those results that come when performing an inner join. As full outer join are rarely used, the main focus for this lesson will be left and right join. When we are writing the SQL query, make sure the left table name is written after the from keyword and the right table name is written after the join keyword. Performing left outer join will select rows that satisfy certain condition between both table A and B, and also includes rows in left table that don't satisfy that condition. Left join can also be written as left outer join. Let's understand left join with an example. Consider we have two tables, orders table on the left with order ID, customer ID and order date, and customers table on the right with columns customer ID, name, country. Now you need to extract for each order the name of the customer. So based on the definition of left join, we just select all the rows that satisfy a matching condition. So here the matching condition is this, the customer ID, and all the rows. So basically, based on the definition of left join, we just select all the rows that satisfy this matching conditions and all the rows that don't satisfy this condition but are in the left table. So the left table here is the orders. Here all the rows on the left table satisfy the condition because customer ID 1 2 shown in the left table have a corresponding record in the right table. So the result of this query will be like this. Let's now understand a right join. Performing right join or right outer join will select rows that satisfy certain condition between both table A and table B, and also includes rows in the right table that don't satisfy that condition. Let's understand right join with an example. Consider we have the same two tables, orders on the left and customers table on the right. Now you need to extract for each order the customer ID, the order ID and the name of the customer. Based on the definition of right join, we just select all the rows that satisfy a matching condition and all the rows that also doesn't satisfy this condition but are in the right table. Here first two rows on the right table satisfy the condition because for customer ID 1 2 we have orders, while for customer ID 3 we have no orders yet. So the output table will contain all the corresponding rows that satisfy the condition and also the row for the customer ID which 3 for the customer ID 3 which doesn't satisfy the condition on the right table with a null order ID. So the result will be shown as here. So for the customer ID 3 the order ID is null. Let's discuss a key observation while performing right join. When we perform the right join, currently the table on the left is orders and table on the right is customers. Now if we just interchange left to right and right to left, now the customer table is on the left and the orders table is on the right. Okay, so basically we have interchanged two tables. Earlier it was orders on the left and customers on the right. Now we just interchanged and then just change this right to left join. Okay, now we have customers table on the left and orders table on the right. Now you need to extract for each customer the customer ID, the order ID of the order they made and the name of the customer. Based on the definition of left join, we just select all the rows that satisfy a matching condition and all the rows that don't satisfy the matching condition but are in the left table. The left table here is a customer. Here all the rows on the left table don't satisfy the condition. Only the first one for the first two rows we have the orders, but for the third row we don't have an order. So the result of this query will be as shown here. For the third customer we still show because it is not matching the condition, we have the order ID as null. So let's conclude something interesting here. We have just interchanged the tables and changed the right to left and we see the results are the same. So instead of writing a right join, we can just interchange the tables and just perform a left join. So in most of the cases people use left join by interchanging the tables even if they want to perform the right join, as it's commonly followed standard. we learned uh, until now we learned basic SQL statements and left and right joins. While working with these items, we have mostly dealt with low level data, that is like just running queries to show the rows. Imagine you want to analyze number of orders made by each customer in a month or a year, or if you want to find out what are the sales this quarter. So basically you want to you might need some functionality to aggregate the data like this. SQL is very good at performing aggregations. So like for example, you want to count the number of rows in a table, or want to sum up certain value for all the rows, or take average of all the rows, or if you have some pricing table, you want to find minimum and maximum price spent on a product. So these are all the functionalities SQL provides, and SQL is very good at performing at these aggregations. So let's dive into each of them, but before that let's briefly talk about null. Null means basically there is no data, and it's different from zero. For example, due to any bug in a program, there could be a order created and there was no date. There was no date while inserting or updating the record. So basically here the date value has no data, so it's considered null. But sometimes there could be a case for some X company, there might be have some they might have defined some logic. So for example, if there is a column named membership and has a value called premium, then the customer is a premium customer, and if the value for the membership column is null, then the customer is a non-premium customer. So each business might be having their own logic defined for null. So it's important to understand the significance of why the value is null. Difference between null and empty string. I have created a table where the name column, there is no constraint for the value to be null, but for gender the value cannot be null, so I am including a constraint. If I just insert a record with no value for the name, then the name value has null, because we are not passing any data for the name. So here the name is null. For the second insert record, I have included a name, but I am passing a empty string. So this is not same as null. Let's see how this data gets stored. So for the first insert I have a null, but for the second insert I have a blank string. So this is the difference between an empty string and a null. To filter null values, you can't use equal to null in the where clause, because null is a property of the data and it is not same as a value like 0 or an empty string. So to filter a null value, you have to use something like is null. So if I just query this, I just get the record which is null, and to fetch the records which are not null, you can just include is not null. So if I just query this, I get the records that are not null. In the students table, we have 4 rows, and for the column name, we have one empty string, one with property null, and others as John and Rachel. For the gender column, we have 3 male values and 1 female. Let's understand on how the count function works for this data. Count function returns the number of non-null rows for a given criteria. If you use the count function on gender, it returns 4, because there are 4 non-null data for this column. If you use count function on name, it returns 3, because there are 3 non-null data points and one of them is null. Let's see. For gender, it returns 4, but for name, it returns 3. Here is the payment table where it has data between a customer and the amount they paid. To find the total amount paid by some customer with customer ID 269, just use the sum function to compute the total amount paid. And one thing to note here, the sum function considers null data as 0. So let's run this and see. The max function and the min function returns the maximum and minimum value in a column, and the average function returns the average of all the values in a column. Existing query we have is for one customer. Consider if you want to extract the total amount for each customer. So here we are just finding the sum, the amount paid by one customer. If we want the total amount paid for each customer, so then in our existing this query, we just remove the where clause and see what happens. So if I just run it, this is not going to work because the sum function is not intended to work this way. To resolve this, we have the group by. Here I am grouping by the customer ID. So if I run this query, I will be able to see the total amount paid by each customer. Now the list is not ordered properly. Let me use the order by keyword on customer ID and run the query. Now the query result will be shown in a more readable way. Now the list is showing customer ID in a sorted order so that it's more readable. Consider if you want to have more granular chunk of data. In this case, if you want to extract total amount paid by a customer for each staff member, then we can include the staff ID in the group by. This will give me the total amount paid by the customer to each staff. If I run the query, you can see we see what is the amount the customer paid for each staff. Here we have ordered by the staff ID, first the customer ID and then the staff ID. So in the result we see first the customer ID is ordered and then the staff ID. The distinct statement is used to return only the distinct or different values. Inside this table, in the payment table, if we just count on the customer ID, we roughly get around 16,000 records. Sometimes you only want the distinct values, that is like the unique customer IDs, then it's going to be around roughly 600. So this is a syntax on how you can use the distinct keyword. The having clause was added to SQL because the where keyword cannot be used with the aggregate functions. For example, I am filtering the data where the sum of amount is greater than 100. If I just run this query, it doesn't work. So filtering data using aggregation won't be supported by the where clause. For that we have to use a having clause or a having keyword, so whatever it is. So basically now we get all the customers whose sum is greater than 100. The case statement goes through conditions and returns a value when a condition is met. If nothing is met, then it will return whatever is in the else statement. If the else statement has nothing to return, then it returns null. Consider you want to extract a super customer and a starter customer. A super customer is someone whose amount is more than 100, while a starter customer is someone whose amount is less than 100. Here we have used the case statement where we have a condition, the super customer and the starter customer. So if we just run this query, we will know our super customers and the starter customer. We can do the same thing that we used by the case through a having clause here, but we need to write two different queries, one for super customer and one for starter customer. Here it's just two. This will be troublesome if we have more items to categorize. A subquery or inner query, or also called as nested query, is a query whose result is used for another query. Let's see a few examples. Let's say we have two tables, customers table and a payments table. In the customers, we have 4 columns: ID, name, age, points. The payments table has 3 columns: payment ID, SP ID, customer ID, CID, total amount paid basically. So each customer will have only one payment record, so this is a one-to-one mapping. If you want to write a query to get all the payments amounts of customers whose age is greater than 30, you can use a subquery in such cases. So basically what we are doing is the subquery is fetching you all the IDs of customers whose age is greater than 30. So in this case, this subquery will return these two customers, the IDs of these two customers. So basically 2, 3, because their age is greater than 30. And then it is used by the parent query, which fetches all the payment records for these two customers. So basically it fetches this customer ID 2 and customer ID 3. Consider similarly, if a company asks you to give 1000 points to all those customers whose total amount is greater than 1000. In such cases, we can also use a subquery. So we are just updating the customer table. So basically for all the customer ID, this subquery first fetches all the customer IDs whose total amount paid is greater than 1000, and then in this case this subquery will return just 2, because the total paid amount is greater than 1000 for only this customer. And then we are just updating the points 1000 for this customer. Consider if the database is too huge, it might take long time to run the subquery. To optimize, we can have the inner query run first and store it in a temporary table and use it directly in the main query to optimize. So sometimes a query might take a long time, so in such cases we just run the subquery first and store the result of this query in a temporary table, and then we directly use it in the main parent query. This will optimize the subqueries. Basically you are increasing the speed of the result of this query. If the data is not structured properly, you need to clean the data. Let's discuss 2 use cases for data cleaning. Consider the customers table stores the 4 numbers, which includes the country code. Now in some cases you might want to just extract the country code and the remaining part, which is the mobile number, separately. That is one use case. The other use case is, consider you have the customer schedule table that stores the day, month, year separately. So the day has a data type of string, month has a data type of string, and year has a data type of string. So now if you want to extract like in this format from this table, which is like a year, month, date, you might need to clean the data. Let's see some functions in SQL to clean the data for such cases. Using the left and right functions in SQL, we can extract a substring. In this case, for extracting the phone code, you can use the left function with the first parameter as a column name, and the second parameter is the number of characters you want to extract starting from left. In this case, you are extracting +91 because 1, 2, 3. So 3 characters. So the left function will extract the number of characters you mentioned here, starting from left. Similarly, right function extracts a substring whose length is mentioned in the second parameter, and the column name is mentioned in the first parameter. So basically, the length is also a SQL function which returns you the length of that the value in that column by just mentioning the column. So here the length of this value is 14, and if you subtract 4 from it, it will be 10. So this function will give you the last 10 digits, which will be the phone number, in this case the mobile number, excluding the country code, because the length of the we are excluding the length of the country code here, so which will return just the last 10 digits. Position function in SQL allows you to find the position of a substring in a column. So here the position of hyphen in the column phone will be 4. String position is same as position. There's no difference between them. Previously we were explicitly defining the number, like this is the length of the phone code. That is what we have assumed. But in most cases, the phone code can be more than 3 characters. So for such cases, this query will be returning incorrect phone code. So basically, to avoid such issues, we can find the position of the hyphen in a phone, and this is 4, as seen here. So we are just subtracting -1, so which is 3. So for such cases, if hyphen is if the phone code is 4 characters, so then the hyphen will be after the 4 characters. So yeah, in such way you can extract the phone code correctly. In case you need to get a lowercase characters or uppercase characters, lowercase or uppercase of a column, in SQL we have the lower and upper function. This example returns the lowercase of name column and uppercase of name column. Sorry, here it's lowercase. It's just a name column, and yeah, here it's just the name column. So we are just using this lower function on the name column, so this will be returning the lowercase letters, and we're using the upper function on the name column. This just returns the uppercase of the characters of this name column. In case if you need to concatenate 2 strings in SQL, you can use the concatenate function. Pass all the arguments. If you want to just concatenate columns, you can just give the name of the column. Here if it combines name with an empty name column with an empty string, and then age column, after that with a static string that says years. So the formatted text will be as shown here. The result will be something like this. Similarly, similar to concat function, we can use a pipe. So instead of using concat and passing all the arguments into it, we can use a concat, similar like a pipe function. Pipe in our keyboard, we see the pipe. So basically, there you can use that, and just we can concatenate name pipe, and here we have empty string. Then we use the pipe again. So this will concatenate the complete string, and the result will be the same. Consider we have a customer schedule table which has a day, month, year. Now the data type for day is a string, for month is a string, and also for year is a string. Now if you want to extract dates in the date format, okay, like date, like year, month, date, if you want to extract in this format from this table, we can use we can just concatenate the string. So first we concatenate year with pipe, and then we're just concatenating year hyphen, this will just return the date part. Here this function is returning the number of the month. So basically if it is February, it will return 2. If it is March, it returns 3. And then we are using again concatenating with hyphen, then day, which is this one. So here we are using casting as date. We are casting this concatenated string as date. So basically that defines that that this string is in a data type format. So then we are using alias as a formatted date. Yeah, the result will be something like this.